So today we have with us Dr. Gopal Sarangi, who will be speaking on the topic Unpacking India's Energy Transition and its Complexities. So before I introduce the speaker, just let me give you a background very briefly. You might have heard that in COP26, the Prime Minister Modi announced at Glasgow that India has to achieve energy transition, or India has already made a commitment to achieve energy transition. Why? Because as per the IPCC reports, if the present trend of global emission, carbon emission, and methane emission continues, then the mean temperature of the planet Earth will increase more than 1.5 degrees Celsius by 2050, or even more than before 2050. And even there are some predictions that the mean temperature of the planet Earth may increase even 2 degrees Celsius compared to the pre-industrial period. Now there is an urgent a call by IPCC and the global community to reduce this carbon emission. And for that, the main contributor is basically the energy sector. And now worldwide, now there is a discussion that we have to reduce the carbon footprint of the energy. And how to do that? We have to go for renewable energy production. And so that is basically called the energy transition. We have to reduce the use of the fossil fuel and go for using more and more renewable energy. It could be solar, it could be wind, it could be nuclear, and of course, being part of PA, there would be also a lot of importance on nuclear energy in the future. And again, by 2070, India will achieve net zero emission. Okay? And by 2030, which is very near, India's Prime Minister Modi has announced that India's renewable energy production should be at least 50% of the total energy basket. So that is briefly about actually India's commitment. And by and large, if you see the trend, India is moving in the right direction. And we may be able to achieve those targets at least by 2030. Probably India can achieve the 50% target of increasing having the renewable energy production in the energy basket. But Gujarat is going to have actually world's largest solar power plant and wind energy plant, of course, done by Adani groups. That will be largest, world's largest. So. And if you see also the other states, they are also doing a lot of things to increase the renewable energy production. So we will be discussing actually all the challenges. So it's not only the energy transition, there has to be just transition. That means how do we phase out the coal? People who are employed in coal sector, can you just tell them that stop coal production? Can you say the workers working in the coal industry that from tomorrow you don't come? So how do you do this actually transition? So it is called just transition. So our energy transition has to be just transition. So today we have with us an expert, Dr. Gopal Sarangi, who will be speaking more on this. Now let me introduce Dr. Sarangi. Dr. Gopal Sarangi is an economist with more than 20 years of research and consulting experience. His primary domain of research covers energy market and regulation, intersection of energy technologies, fuel and resources with public policies, social systems and process, energy and climate nexus, governance and institutional analysis of energy, transition questions, geopolitics of energy, and impact assessment of energy and environmental interventions. He has contributed as PI and co-PI and team member to several collaborative projects. Who is credited, he has published several peer-reviewed research papers in the domain of his research and has been invited to deliver talks in several national and international forums. He teaches courses in energy economics, energy and sustainable development, carbon market and energy, development economics, managerial economics, and environmental economics. So with this, now I invite Dr. Gopal Sarangi to start his presentation. Over to you, Dr. Sarangi.
Thank you very much. I hope that I'm audible to all of you.
Yes, very clearly.
So thank you once again for inviting me, and thanks for a nice introduction, Dr. Das. So I feel privileged on 3 counts. One is that I'm part of this research team and each of you I consider as highly enriching experience in different domains. And that will be really learning experience for me. Second, I also feel privileged because I have been invited for the discussion today. Just to put a disclaimer, I am not an expert. I am still learning. So I hope that I'll get your inputs as well. And third and last count, I also feel privileged. What I see is that there are a couple of participants today whom I always learn. They're very senior scholars. Professor Tapan Sarkar from Australia, Professor Devajit Pali, those who have been acting as my mentors are also here. So what I'll do is that I'll take you through 45 minutes on different aspects of how the energy transition and its complexities are actually unfolding in Indian context. And then we will have some question and answer session, or maybe you have some doubts. You can stop me in between, but I would request you to please hold on your questions towards the end, and let us throw some basically to unfold some of the complexities that are associated with this energy transition roadmap. And when I say so, the idea through this presentation basically not to answer some of the questions that are actually being around energy transition. The whole idea basically is to ask questions rather than answering them. What I believe is that there are a lot of areas.
Can you make it now? Dr. Sarangi, can you make it full screen?
Yes, I'll do that. I'm just giving a background of that. I'll just do that.
Okay.
So the whole idea basically is to bring in those complexities instead of answering those questions, because there are many unresolved questions. Why is it so? I'll unfold some of these. Let me go through the scheme of the presentation that I plan to do. I don't know whether you can cover everything, but we'll try to at least throw some light on some of these critical issues. We'll basically try to, I got there are a lot of metal on it, but what I plan to do is that let me start by characterizing what exactly energy transition constitutes and what are the imperatives. And there are also discussion on net zero, which Dr. Das also indicated. I'll be throwing some light on those. And there will be discussion on how this transition idea is getting unfolded in Indian context and why, basically drawing from two examples. The one is the coal lock-in or carbon lock-in. The other one is the dichotomies around moving from the centralized energy systems towards the decentralized energy systems. Then some concluding remarks, and then followed by some questions and answers. And while you're looking at all these, the idea basically, as I said, is not to emphasize on what is being written on the PPTs, rather to focus would be more on the discussions and the deliberations. So let me begin with what exactly we mean by energy transition. Now, if you look at the transition debate, what is happening currently is that the transition debate is mostly hijacked by the discussion that how would you move from coal to renewables. But that's actually not capturing the debate in its totality. Why? Because the transition debate is quite complex, and it has actually dimensions which are very difficult to even comprehend, basically to comprehend. Now, why is it so? Because if you look at what is happening, that we know that the current energy systems are unsustainable. And when you talk about unsustainability, what comes to our mind, what strikes to our mind is that basically it is reliant on fossil fuel. But that's not the story. Yes, the large part of the story is around how to move. I just said how to move. That means there has been also a debate on at what rate you would be moving. Will it be incremental or radical? And we'll be discussing all those as you go along. But basically, when you talk about the question of sustainability, it actually involves a whole gamut of issues. It has implications for the society. It has implications for the economy. It has implications for environment at all scales. All scales. I can give an example. For instance, if you look at internationally, globally, the discourse that has been happening is that how would you move, how the geopolitics of energy transition is actually moving, okay, temporally. There is also a spatial dimension into it. What do you mean by that? When I say temporally, if you look at simply, I can give a crude example. Let me think about this. Let's say that what we are earlier depending is that basically if you look at it from the Indian point of view, we are trying to import, because we didn't have adequate domestic energy. So we're importing huge amount of oil and gas, almost 80 to 90% of it in different time periods from other countries. Now that dependency is still there. It's not that it's completely disconnected or moving, or we have shifted from the oil and gas to renewables. But what is happening is that oil and gas continues. At the same time, we also started importing huge amount of panels, solar panels from China. And not only that, if you look at what is happening recently, that we are also trying to figure out that we need huge amount of critical minerals to support the sustainable energy system that we're talking about. We talk about cobalt, you talk about other minerals, whatever are there. So the process basically that at geopolitical level, at international level, global level, also there is a temporal shift in terms of the geopolitics of energy, in terms of the way import-export is happening, in terms of the resources that are imported and exported, in terms of the location of the country. You are importing oil and gas from other countries now. When you move from oil and gas to solar, then we imported solar panels from China. Now we are relying on, trying to at least rely on Australia and other countries for critical minerals. So there has been a temporal and spatial dimension when you look at the geopolitics of energy. And you think of, as I said, it happens at all scales. One scale is when you talk about geopolitical politics of energy. Come down at national scale, there is a whole lot of issues. We talk about this coal debate. How do you transit? Will throw some light if time permits. How do you move from coal to renewables or coal to green hydrogen? Are issues which are of national importance and will have implications for the subnational entities, significant implications. Not only that, one debate which Professor Devajit Palit is here, who has extensively worked on this area, is about, and we keep on talking on certain discourses at a very low scale, which have not been really received the attention that it desires, that it requires. For instance, how the energy use in agriculture is getting unfolded, is actually getting transited. Let's, for example, there is focus now on Kusum scheme. So how do you move from the grid-based, largely fossil fuel energy system to agro-PV system? How do you unfold? How do you think what kind of implications are happening when you move from a grid-based household energy system to a system which is based on rooftop PV? Now, these are essentially the questions which have not really received a lot of attention, even though there has been a whole lot of research which has been going on. Still, those who are researching, as I said, there are a lot of senior researchers here also, they are also still struggling. What would be its dimension? What kind of connections it has? So, as I said, that it has a scale issue. One is you look at it from geopolitical level and global level. It has also regional implications, which are not spoken about. I have certain slides specifically talking about how the debate on transition is getting unfolded, demystified at regional level, also at a subnational level, and importantly at a very micro level. When you talk about household energy use or industrial MSME energy use or energy use for agriculture sector, everywhere you see there is a transition happening in a very different way, where the characteristics, nature, everything is different when you look at the scales, when you look at the sectoral types and all that. Now, this debate is not about technology. Why? Because technology, yes, is very disruptive. But when you bring in new technologies, I mean, when you look at how technological shifts are happening, and that is actually a life trajectory. If you look at, let's, for example, I have one slide, in fact, one of my paper is focusing on that, trying to look at what supports technology. If you look at, let's, for example, the growth of solar or wind energy in this country, what you see that initially it is publicly supported instruments. I have a slide on that. Then we move to a completely, or somewhere in the mix of publicly supported and privately driven or market-driven kind of an approach. Then you move from a market-driven to completely market-driven approach. Now, not only that, and all these, as I said, technological shifts are basically influenced by the political economic constraints, by the regulations that are there governing the technology, the way the tariffs are designed, the way the pricing mechanisms are evolving. And when you look at the implications of these technological shifts, which are again influenced by all these developments, we'll have a very complex. And that is actually, if you look at the way the things are happening in eastern part of the country, most important aspect is to look at the implications, the way the resources are transferred, what kind of implications it will bring in for the society. And when you bring in society and economy together, when you bring in regulation market on a different platform, so what kind of implications is going to create is something which you need to focus on. Now, I just said that already have discussed, I don't really want to spend much time on this. I said that scale, size, geography dimensions of transition are very, very important. It happens at a different scale in a very different way. Geographically, it's also going dramatic changes happening. Technology, regulation, behavior, as I said, how the transformation would happen also depends on what kind of behavioral changes are expected. If you look at the life mission, which has been put forward in the as pointed out by Dr. Das in the COP26 Glasgow summit, is also important aspect of influencing your energy consumption, energy production, everything, right? So there is a lot of focus now on that. Then, as I said, that there are multiplicity of actors. You are no more confining to only single set of actors. You have government playing important role as an incentive creator. You have private sector, market. Okay, we look at what is happening in the case of the business units. Whole lot of efforts have been taken towards net zero. There is a whole lot of efforts taken in terms of decarbonizing industrial units. Community scale, non-state actors. So a whole lot of actors interacting in a very complex and a very different way to create this energy transformation, energy transition possible, basically contributing to the way the energy transition is happening. Now the question, why energy transition? I think part of this question was answered by Dr. Das. I don't really want to go back to look at the climate problems, but rather look at the energy transition debate is surrounded. I think this is a very well-known diagram. Everybody knows about it. There's nothing new in it. But what I'm trying to bring in, if you look at this particular diagram, what it unfolds, that energy constitutes 3/4 of the GHG emissions. And if you look at the annual total GHG emission today, it is close to 50 billion tons of CO2. And as I said, that energy is the important or pivotal sector which needs to be, because energy at the same time is a victim as well as a culprit. So if you look at the way the energy sector is contributing to the GHG emission, so energy has been placed as in the heart of the entire transition debate, in the entire climate change discussion or discourse. And if you try to unfold what is happening within energy, you see that there are certain subsectors where you can actually easily address some of the climate change problems, because energy, there are certain sectors which are, of course, they are called hard to abate sector. But energy, on the one hand, is actually contributing, the major contributor of GHG emission. At the same time, energy also can act as a panacea in the sense that you can bring in the transformation which is possible to address some of the climate challenges through the change in the mode of energy production, through the change in the mode of energy consumption. Now, interestingly, this diagram, again, some of you may have seen that, but quickly just to throw some light, it's coming out of this. Interestingly, if you look at the way the annual CO2 emissions are happening globally, regionally, what you see is that if you look at, let's for example, Asia, China, India, the CO2, the annual CO2 is expanding, but for other regions, it is contracting. That's the contrast. You can see that. So you see that, let's for example, globally, but of course the data is not updated, you see 35 billion tons of CO2 is produced annually. It's absolute number. And out of these numbers, you see that major developed countries are contracting, and the developing countries like China, India are expanding. But this is not telling you the truth which is behind. Let me unfold those truths, those kind of information which requires to be justified, and for which the global debates happens every year through COP. Now, one of those debates is, as I said, this is just a replication of what you presented earlier. If you look at this diagram, it clearly tells you that China, India are expanding in terms of annual CO2 emissions that are being emitted from these countries. Whereas if you look at what is happening to developed countries like United States, Germany, and other countries, you see there has been a declining trend. But as I said, this is not the complete story. Why is it so? If you look at this diagram, this tells you what is happening there. So one is that the debate, if you look at CBDR debate, which is happening globally in the climate change discourse, if you look at what is happening even after the Paris Agreement in COP26, whatever debates happening around that every year, you see that part of this is around this discourse which is presented in this slide. Look at what is happening to per capita CO2. Now, USA, even though it is showing a declining trend, the one per capita CO2 is close to 13 tons of CO2 per year. And look at the largest emitter, China. It is 1/3 of what is actually happening in USA. India is nowhere. It's only 1.69 tons of CO2. The point is everybody knows about that. The point is that the whole debate that is happening around globe about, let's, for example, I bring in the question of carbon budget, right? So there's a fight happening that every developing country is trying to get a larger share of carbon budget because of this. The saying that, okay, if you look at the way the developments have happened in developed countries, you already have consumed significant amount of carbon budget. So please leave us more space to emit, because development and emission has a very strong linkage. You'll throw some light. And of course, the decoupling, through the decoupling efforts, it has been realized that the development and the emission generation could be decoupled, but still the decoupling rate is not that high in developing countries, given the fact that markets are quite imperfect in these countries. Now, if you look at, this is a very clear and very interesting diagram, which I picked up recently, I think today morning, to show you that the per capita emissions, if you look at that, there are three sets of countries primarily. One is that developing countries like India, China, other countries. Of course, China is much ahead in terms of per capita emission, what we have. But if you look at the developed countries, the high emitting countries, even within high emitting countries, there are two sets of countries. One, quite developed like USA, Canada, and European Union. Of course, European Union doesn't have significant amount per capita emission. But if you look at particularly USA, China, and Canada and other countries, the per capita emission is quite high. But there is a good group of countries which are not that much developed. Okay, of course, they are somewhere in the middle, but they have not been developed as compared to the US and other countries. They're Middle East countries, and they have actually experienced a significant rise in the per capita emission due to the way the energy consumption and energy production happening in those countries. So if you look at that, within the high emitting countries, you have two sets of countries. One, which are really developed and they have already having high per capita CO2 emissions. But there is a group of countries which is like, let's say, Middle East countries, Qatar, Saudi Arabia, and all that. They also have high per capita carbon emissions. It's primarily because the way the energy is being produced and consumed in those countries. So it is not always equal. There is also debate going. They also want more share in terms of carbon budget. They want the slowing down of the way the phase down is happening in terms of coal and oil and gas. So the point that I'm trying to bring in through this diagram is that different countries are heterogeneously placed when you talk about carbon emissions. So getting a deal amongst countries in these negotiations are increasingly becoming more and more complex. And if you look at the history, I don't really want to get into that. There has been always a fragmented way of bringing the agreement between the developed countries and developed country when it comes to looking at a particular action plan on climate change in relation to energy. Now, if you look at that, this is an interesting why I thought of including this, because what you see here is that it's essentially trying to, that is when you talk about the CO2 emissions or basically the climate related negative factors. If you look at that particularly the CO2 emission, what you see is that there is a distinction between the production based CO2 emission and the consumption based CO2 emission. What you see here, I've taken India as a representative country for developing countries. What you see is that there is a high correlation. Clearly, it can be visible here between the per capita GDP and per capita CO2 emissions, both in case of production of emissions and or production-based emissions as well as the consumption-based emissions. So there is a high degree of correlation. That means that the decoupling has not been happened in countries like us, because you need more space to develop before you get into the decoupling debate and before you realize or take actions to decouple things. Now, if I bring in the same diagram, okay, same variables in UK context, you see that there is a clear decoupling happening. Of course, as I said, the per capita emission continues to be high. So if you look at consumption-based CO2 and production-based CO2, so you see that there is a decoupling in terms of the GDP growth rate as well as the emission rates. So you clearly see there is a distinction between these two. Now, importantly, I thought that this is a bit complex, but I thought since I teach this course, I thought I'll bringing in few dimensions really. Everybody knows about the carbon border adjustment mechanism, which has been introduced in European Union. And you know, there is a very strong linkage between the carbon border adjustment mechanism, basically carbon tax, which will be imposed on the imports to countries of European Union. Now, why it is important? Because when you look at the carbon market, which has been I mean, one of the well-known carbon markets cap and trade system is the European Union ETS, emission trading scheme. Now, what is happening in those countries is that when you bring in a cap and trade mechanism and try to bring in stringent regulation for industries operating in European Union, what has been observed is that the difficult industries, hard to abate industries, are trying to shift away from European Union and locate the other countries where the environmental regulations like this are less stringent. I hope that I made my point clear. Basically, I'm trying to say that when we bring in the stringent regulation through the European Union ETS, there is expectation and even there has been a realization that those who are high emitting industries may move away from European Union and locate in some other countries where the regulation is less stringent and do the production and sell back to the European Union countries. Now, in order to get rid of this, they have introduced this CBAM. They said, no, that's not possible. Why is it so? Because I told you that there is a distinction between consumption-based emissions and production-based emissions. So the most important point for them is to basically the consumption-based emissions. So through the CBAM, and they have come up with a whole lot of regulations recently. And most recent one, of course, there is a Green Deal. Everybody must be knowing about that. Then you also had 2021 Fit for 55 policy. But most recent one is the Net Zero Industry Act, which essentially is trying to realize the CBAM. And why CBAM? I told you, because through CBAM, they want to impose a carbon levy on the goods which would be imported to European Union countries, so that they ensure that the consumption that are happening in the European Union are less carbon intensive. And they are basically trying to map or basically trying to impose a tax on carbon on the goods which would be imported based on the price discovered through the European Union ETS. Of course, this is a bit more complex in the sense that somebody who doesn't really understand the whole thing may not be getting what I'm trying to say. But the point that I'm trying to bring in, that there is a significant difference between the consumption-based emissions and production-based emissions. And basically, in order to get rid of this production-based emissions happening somewhere else and consumption-based emission happening on their own country, they want to create a bridge, they basically create a hiatus through which they'll bring in this CBAM and try to ensure that the goods imported to their country are less carbon intensive nature. Now, and that's basically discussed in the context of carbon leakage, which I told you. Carbon leakage is basically that you produce somewhere else, sell it to European Union countries, and your production, particularly the high emitting or high carbon intensive sectors like steel, okay, they're bringing out stringent regulation for it. So any steel that will be imported to those countries or exported from other countries to European Union would be facing this CBAM. Now, CBAM modalities are being drafted and is going to more and more complex, create complex mechanism trading for other countries. Now, I also told you that the decoupling, right? So we those who have studied economics, they must have studied EKC, environmental coordinates curve. But I think the environmental coordinates curve is demystified through this decoupling. If you look at that, most of the developing countries have started decoupling the growth from the emissions. And you can clearly see, in case of Ireland in this diagram, you can clearly see that there has been growth in the GDP. At the same time, there has been decrease in CO2 emissions, primarily because of the efforts being taken in terms of the renewable energy front. So if you bring in the middle way, renewable energy growth or green hydrogen or other areas of improvement, you see the decoupling is possible. But decoupling is not that easy because decoupling has a cost attached to it. That is why if you look at that in developing countries, bringing the decoupling through the efforts of net zero or whatever it may be is not that easy. That is why developing countries are basically trying to buy in more time so that decoupling happen over a longer period of time rather than shorter period of time. Now, let me quickly go through this. I think, please, Dr. Das, stop me whenever you want to stop me. I can just let me know before 5 minutes when I need to stop. Now, if you look at this, yes, please. So, if you look at this net zero, why is it so? Yes, Dr. Das. Anything you like to say?
No, I was saying that you can continue, no problem. You can go up to 4:45.
Okay, 4:45. Okay, that's perfectly fine.
Then we have 15 minutes discussion.
Sure. So what you see here is that why there is a need for net zero. Now the question boils down to the fact that why can't we have carbon neutral kind of an economy? There is also discussion why can't we make it only zero? Why net zero? The question boils down to the fact that there are industries which are hard to abate. Now, particularly if you look at, let's for example, two industries. One is the aviation industry. The other one is shipping. Now, there are complexities associated with it, not only in terms of reducing the emissions, also in terms of attributing the emissions. For instance, let's say if a flight is, if I give a very crude example, a flight is moving from, let's say, New Delhi to Perth in Australia. Now, the question is that the emissions that are actually coming out from this flight, which country is going to take that emission? Or whom are you attributing that emission is a question, and for which there has been some effort made in the Paris Agreement in terms of CORSIA. That means basically they realize that it's not possible to reduce emissions, and there are mechanisms developed to figure out who is going to take that part of the burden of emission. That's one question. Second is also, let's for example, if there are sectors where the chemical processes itself is creating emissions or generating emissions. Third is that there are technological advancements happening in developed countries, but it has not been really transferred, which is supposed to be transferred in CDM under the CDM scheme. Basically, CDM is a clean development mechanism introduced on the Kyoto Protocol. We don't really want to get into that because of time constraint. So it is expected that the projects that will be implemented by developed countries in developing countries would be benefited by technological transfer. Even the argument that the funds transfer would happen $1 billion every year has not really been taken place. And the idea basically is to bring in technology which would be helpful or which will basically help industries to reduce emission. That has not really happened. Let's, for example, you talk of cement industry, steel industry. There are certain technical processes which basically you cannot really you cannot really reduce the emissions to zero. And that is why net zero is something being discussed. And there is also a discussion which is happening around the carbon market is about carbon avoidance versus carbon removal. So carbon avoidance is more futuristic. Let's, for example, you know what is the total size of carbon budget available, and you want to create a energy system which is less carbon intensive, you can go for renewables. But carbon removal is basically reducing the carbons which is already there in the atmosphere. For instance, let's say you take certain actions, okay? Let's, for example, you do the afforestation. So afforestation would help you to remove the existing carbon. So the net zero discussion or debate is around this, that whether some countries can take more action in removing carbons and whether countries can take some actions in avoiding carbons. So there is a clear distinction between the removal of the carbon and avoidance of carbon, which actually takes you the idea of net zero. Just to throw some more light on this, if this particular diagram tells you that how countries have committed in terms of the achievement of net zero. If you look at that, the time trajectories that have been spelled out by countries are different. So if you look at, let's for example, start with the green countries colored, whose color code is green. You see that some of the countries are already carbon neutral. So when you talk about net zero, it's not something new. There are countries, let's for example, you talk of Bhutan, you talk of Madagascar, you talk of Gabon, you talk of, let's say, Suriname. So these countries are already net zero. Why? Because whatever carbon emission is happening in those countries, the absorption power, sequestration power of carbon by those countries are much more than whatever they emit. That means they're not only helping them, also in certain cases they're helping other countries, because whatever amount of carbon emission is happening in their country, they already have the capacity to absorb those carbon. As I said, there are carbon removal processes, or partly it is done by the afforestation. See that the countries which are rich in forests, they already are carbon neutral. So there are other countries, those who have actually placed differently in terms of timeline. So for instance, India has said 2070, China has said 2060, and several countries, most of the countries have kept it for 2050. So we see that there is a heterogeneity in terms of timeline which has been stated for the carbon net zero. And there is a reason I said, because when you basically, as I said, that for a country like India, you cannot really commit to be carbon neutral or net zero by 2050, given the path or given the kind of trajectory, development trajectory that we have, given the resources, carbon intensive resources that you have. Similarly, same for China. Okay, and if you look at the way this has been put forward in the entire declaration mapping, so you see that there are 4 different kind of declarations that have been made. So some of these countries have spelled out their domestic laws to make their country carbon neutral. For instance, USA, Germany, Sweden, and all these countries are countries, developed countries, those have included carbon net zero in their law itself. The certain countries, those who are actually at the framing of policy, there is a laws are, while laws are mandatory, policies are not mandatory. Particularly at least in the Indian context, there has been a debate happening in one of the electricity laws context. You realize that the policies are not mandatory. They're more like guidelines stated by the state government, they may be achieved, may not be achieved. So you see that some countries have already enacted laws around net zero. That means they're binding themselves to be net zero by a certain time period. There are certain countries those who have drafted policies. So that basically policies are they're basically stating the wish list, saying, okay, we'll be doing this. Okay, of course they're doing it, but they are still in the policy level. They have not really converted those policies into acts. There are certain other countries, those who have only declared or they have only pledged to be net zero. Let's, for example, South Africa, Ghana are the countries those have pledged to be net zero, but they have not committed this as either as a policy document nor have converted this into law. There are certain countries those are actually proposing this. They have not really gone beyond that proposal or discussion. For instance, Indonesia, Malaysia, Bangladesh are proposing it, and they're trying to be part of this net zero group by a certain time period. So when you look at this, it clearly tells you that when it comes to implementing the net zero, it depends on what kind of pronouncements that you have in a country, whether it's an act or it's a policy or it's only at a place form or you don't have it, it is at a discussion stage. And this is very clearly spelled out in the next slide, which pictorially capturing the declarations by different countries. You see that these deep blue, deep green are countries those have committed in terms of enacting the law. There are policy countries, those have like India and other countries, those have drafted policies for net zero, and there are certain countries that already achieved. I told you about that. There are also certain countries those are proposing it. So you see there is a heterogeneity in terms of achieving the net zero, in terms of stating the timeline. And this is, again, clearly, this is not a very old, a very recent data. In fact, recent last year data. But if you look at the recent data, there is more commitments in terms of emissions. 90% total global emissions have been committed through the net zero. That means countries those have committed net zero, if you aggregate them, so it basically covers 90% of the global emissions and 90% of GDP. In terms of population, 85% of global population are residing in countries those who have committed for net zero. You see that in terms of countries, it's 136. And in terms of companies, I think the companies number have really increased over time in the last 1 year. It is more than 1,000 now, I believe that. So you can check the number. I think that number is not sacrosanct because it's a bit old. Now, in terms of, as I said, that if you look at the net zero targets, in terms of global emissions coming out from different countries, you see that India, for instance, is the absolute emission coming out is 7%, but there is also debate around that, whether India should go for the commitment or not. But anyway, we don't want to get to that. The idea basically is to figure out that those countries that are committed for net zero are having different emission, different amount, different magnitude of emission coming out from these countries. Now let me take you through the debate on energy transition. And I just said that the idea basically is to look at why there is a need for energy transition and how the question of energy transition is transformed in terms of net zero commitments, in terms of the annual CO2 emissions and per capita CO2 emissions. Now, if you look at the energy transition debate, as I said, you see that energy is the pivotal. It has been declared in overarching goals spelled out by the global commitments. Let's say when you talk about SDG Goal 7, you talk of Paris Agreement, you talk of creating new institutions like IS and all that. You see that energy has been in the center stage of the climate debate. Importantly, there has been, as I said earlier, there has been a close connection between energy and climate change, because energy is a contributor to the climate change, and climate change also can be, the issues around climate change can be addressed by changing the pattern and consumption and production of energy. Importantly, you see that this is an interesting slide which I've taken from the Sobhakul's paper. What is it essentially trying to display? That if you look at the temporal trajectory of energy transition, what you observe here, that let's, for example, you say, okay, if a particular source of energy is constituting 25% of the global consumption or global supply, you say, okay, that's the dominating source of energy for a particular period. And what you observe here is that you see that coal took almost 500 years to cross 25% threshold. But for crude oil, it is only 9 to 10 decades. And it is what is expected is that for for the renewables, it might be only 3 to 4 decades. So what is coming out from this diagram clearly is that the temporal trajectory for energy transition is changing over time. Now it is rapidly and increasingly becoming more and more shorter time period where the energy transition is happening or unfolding. What you clearly see here is that coal, as I said, to 500 years, whereas crude oil became the dominant in only 90 years. Now we're moving from, as I said, crude oil and gas to a regime where we'll be primarily relying on green energy, and it might complete globally, it would cross 25%, 30% in next 3 to 4 decades. That's essentially presented here in this slide. I can skip that. Now, if you look at the way the renewable energy generation is happening globally, you see that the wind and solar are more recent compared to the hydro power. Why hydropower has been traditionally basically connoted as a renewable energy. Of course, there is a debate on whether the big hydro should be considered as renewables or not. And that debate also is actually implemented in India. India earlier only considered hydro powers up to 25 megawatt as renewables, but there has been a change in definition. Now all big hydros are also part of renewables. Now what you see particularly in case of wind and solar, you see that wind has been there for last 30 years. In Indian case also starting from 1990 till now, 30 to 35 years. Solar has been more recent. It has been almost like a 10 to 15, not very, or maximum 20 years. Of course, we started long back. As I said, if you look at, go to the history and if you look at the growth of renewables, even in India, you can see that the growth or you can trace the history going back to 1973 and 1977 oil crisis. If you look at how the state nodal agencies, particularly for renewables, have started to grow, many in Indian case also at the subnational level, all started, let's speaking, OREDA, PEDA, all these state nodal agencies have a long history. They have been there for last several decades. But if you look at the real growth, commercial growth of renewables, particularly solar, it has happened in the last 20 years. As I said, it has been there for as a demonstration or as a non-commercial promotional phase for quite some time. So what you see globally also, same experience. You see that wind and solar has not a very old history. It has been growing for the last 30, 50 years, not more than that. More interestingly, what you see here again is that Brazil and Sweden, as I said, are high in renewables, primarily because of big hydro, not because of solar and wind. But if you look at the whole debate on solar and wind, and if you look at the debate around the energy transition, it is primarily boiling down to the fact that how the solar and wind are promoted, not hydro. Of course, the share of hydro, the relative share of hydro, most precisely speaking, is declining. And Brazil and Sweden are high in renewables primarily because of the big share of hydro that are coming, hydro as a source of energy for these two countries. For other countries, it is picking up as these countries are mostly relying on solar and wind. So you see there is a growth in the last 30, 40 years, primarily because of more reliance on solar and energy as renewables. Now, interestingly, what is happening, as I said, there has been a change in the way the energy market is evolving. Now, interestingly, this has also led to change in the geopolitics in terms of the location of energy supply. I just said that when we move from oil and gas to renewables, because oil and gas are actually drawing largely from Middle East countries, of course, OPEC plus countries like Russia and all. But if you look at the way the renewables are actually happening, okay, the market structure or the geography of the market is also increasingly becoming regional, because you're drawing energy from other countries. But now what is happening is that because of the geopolitical change, you are creating local markets. For instance, in South Asia, even though you trade with other countries like Bangladesh, Nepal, Bhutan, the discussion that is going on is that there would be a common market for renewables for all these countries together. And there has been some studies indicating that that is possible. If you look at this particular diagram, this is more of a technical diagram. Just want to throw some a couple of minutes on this. Basically, this diagram tells you that there exists a complementary load pattern. What does that mean? It essentially means that if you look at this diagram, there are three different color codes. You see that the red color is high complementarity load pattern. Medium is the low, somewhere in the middle. Low is the low load complementarity pattern. That essentially means that whenever Bhutan or Bangladesh needs energy, India may not be needing it. You know that when you try to create the peak capacity, part of the peak capacity was stayed for the entire day, only for few hours, because peak capacity is actually utilized during the peak hours only. So what could possibly be done is that during, let's say, India's peak time, peak energy demand time, if India can draw energy from Nepal, Bhutan, Bangladesh, or Sri Lanka, so probably you don't need to duplicate the assets. Similarly, if Nepal can get its or meet its peak demand by drawing energy from demand, they don't need to create the assets. Now, that is possible. This particular diagram studied by World Bank clearly telling you that there exists a complementarity load pattern which can possibly be utilized or capitalized to reduce the asset creation and duplications of assets, and eventually would help countries to meet their energy demands without creating or duplicating the energy assets. That's just, again, a discussion which is happening in the context of regional. As I said, if that kind of possibility can be created, then it would be not like drawing energy from the far off countries by using the transport system, rather creating a local grid, a regional grid within, let's say, in South Asia, to complement each other and reduce the demand, asset creation, and help countries to grow. Now, if you look at, let's, for example, in the last part of this presentation, I'd like to throw some light in next 15 minutes on the what are the complex paths to energy transition in India. I already said that India is moving, and of course, Dr. Das also pointed out this, that there has been a lot of changes happening, and there is a bit of lack of clarity as well in terms of, let's, for example, you talk about 500 gigawatts of installed renewable energy capacity by 2030. At the same time, it is said that the 50% of the capacity would be renewables. So nobody exactly know whether how do they decide how the 500 gigawatt would be equal to 50% of the capacity. Now, there is also strategically a word being used. It's actually not renewables, it's essentially non-fossil fuel. So what exactly constitutes non-fossil fuel has not been very clear. I also told you there has been a change in the definition in terms of the renewables. Earlier, big hydros are not part of renewables. Now they are part of it. Now, as I said, that Government of India has been committing. There are primarily, if you look at 8 commitments made in the Glasgow, and all these are converted into the NDC 2 submission happened last year. You see that 5 of them are quantitative commitments. And if you look at the commitments that have been made by the Indian government, they're primarily short-term commitments. There are also long-term commitments in terms of if you look at the report, LT, I forgot the long-term low carbon growth strategy, and also there is NDC essentially about 2030, or your 2030 agenda is also about 2030. So that if you look at the time trajectory, there are 2 sets of commitment. One is the short-term, which you aim to achieve by 2030. The other one is long-term, which basically boils down to the fact that you have commitments to be achieved by 2070, for instance, let's say net zero. Now, these are commitments where there requires certain kind of synergy between them. As I said, that you don't really know, if you go deeper into it, what exactly constitutes non-fossil fuel is not very clear. How do you say, okay, 500 gigawatt is equal to 50% renewables is not very clear, right? So there are certain clarifications still requires to be involved. And there has been, as I said, that there has been change in terms of the energy mix. There has been a change in terms of structural change, the way the whole energy sector is operating. And there are a lot of, as I said, the market-led reform is happening. You are moving from, I'll bring a slide where basically you're trying to move from regulated regime to a mixed regime, then to a completely market-based regime. Now, 1/4 of the capacity is from renewables. Of course, the problem is that it's not about capacity, it's about generation. If you look at the regeneration, it's only 1/10. So even though you have capacity, you're not able to optimally utilize the capacity. So something is a problematic thing. Importantly, there have been a lot of other developments happening which will have implications for the transition. One of those is basically mission hydrogen, deep ocean mission. Shale gas, as I said, is something which is happening in a very rampant way, increasingly in Indian context. Indian government has identified 16 sites out of 64 basins to be drilled, and private company has been contracted to drill this. But the problem with the shale gas is that when you try to extract shale gas is more like a fracking process. So you need huge amount of fresh water to pump in and mixed with chemicals, and you bring out huge amount of polluted water. Now the question is, what would you do with those polluted water? And unfortunately, the shale gas reserves in India are located in localities which are facing some kind of water problem. Either the water is scarce or water is contaminated. Think of West Bengal. West Bengal has shale gas reserves. West Bengal also faces contaminated water problem. Arsenic contamination is there. Andhra Pradesh has shale gas reserves. Andhra Pradesh faces significant water scarcity. Gujarat has shale gas reserves. Gujarat also faces significant water scarcity. So shale gas brings in, as I said, when you talk about energy transition, when you try to bring in energy transition and unfold it, it's not that easy because energy sector is very intricately connected with other sectors. I can also give you one more example. Let's, for example, how the water, energy, food, climate nexus is getting unfolded because of the agro PV intervention. For instance, let's think about this. If you look at the earlier narrative, which has been put forward by the Dr. Mukherjee and Tushar Saha, you see that electricity was available freely. Large farmers were extracting more water, selling it to small farmers. So you have, when you get electricity freely, you use more energy, and this free electricity, substantial part of it is coming from fossil fuel. So you put pressure on the environment, you get more water extracted from the ground, you put further pressure on the environment, you sell it to the poor farmer, you bring in the inequality dimension. Now all these are getting disruptively changed because of the agro PV. When you bring in agro PV, you are actually creating a disruptive change. How? Because agro PV, whosoever owns it, it not only helps them to extract water, also gives them an opportunity to sell back the energy, extra energy to grid. And the rate at which you should be selling depends on the regulatory commission's decision. So the point that I'm trying, I don't really want to get into those complexities. The point that I'm trying to bring in, that any small intervention, because when we talk about energy transition, we are actually hijacked by the coal transition. That's not the case. Why? Because it's happening, as I said in the very beginning, at all different scales. So there are issues, complexities associated at different scales. You talk of geopolitical part of it, you talk of issues at the national level, you talk of issues at the subnational scale, you talk of issues how happening in the sectoral scale, you talk of forestry, you talk of oil and gas, you talk of ocean energy, you talk of agro PV. There are issues which requires a lot of answers from the engineers, technologists, scientists, policymakers, economists, everybody. And that's not easy. The path is not that easy, particularly for a country like India, which is huge, and every state is actually a market. So markets are segmented. I don't really want to focus much on that because that will take a lot of time to discuss all that. Just quickly go through that. As I said already, told about this. There is also an integration happening between two different sectors. Particularly, we did a project last year funded by British Academy trying to figure out what would be the kind of disruption that might happen in the electric vehicle space. Now, why is it so? Because when you bring in the electricity sector with the electric vehicle, that will be very disruptive in nature. Why? Because let's, for example, don't change the grid. The light that is burning on my head, 70% of it still is coming from fossil fuel. If you bring in electric vehicle, so it will further increase the load, and it might lead to create environmental pressure somewhere else while edging the pressure in New Delhi. Let's, for example, you reduce the pollution here in New Delhi, but create more pollution in Amnugul. So this kind of disruptive changes are not really mapped much. There have been a lot of studies in electric vehicle space, but they're not really looking at what kind of changes, what is exact kind of disruptive change that might happen. I just said there are also implications. Each of the changes will have socioeconomic implications governed by the larger umbrella of the law, policy, and other institutional aspects. Just to again quickly go through this essentially tells you the fact that how much time is left after us? 10 minutes?
Now 8 minutes we have. Yes.
Okay, quickly.
Now
This
37.
essentially tells you the fact that while if you look at, unlike the fossil fuel industry, in fossil fuel, you see that even today, 55% of the energy plant, basically the power plants, are owned by government. But in contrast to that, if you look at what is happening in case of renewables, of course, that's a global trend, is that it is primarily owned by the private sector. So there is a contrast that, and usually there is discussion, debate going on that whether renewables can be considered as a merit good. If it is a merit good like education and health, it is expected that government should supply. But that's not happening. Globally, the trend is that it's private sector which is driving the renewables. Not only that, they're not putting up their own money, they're actually getting money from banks. So there is a question happening that whether when you talk about the installed capacity, are we really serious about it, or is it something else which is driving the private companies to get into this? Now, I'll skip this slide. Certain slides. I'll just quickly go through. This is essentially talking about how the price discovery is happening because for renewables, it was 17 rupees, 12 rupees few years before. Now it has come down to even 2 rupees or around that. Now, this is how the potential renewable energy capacity across states differs significantly when you move from one state to other one. I just want to spend some time on this. Basically, I was mentioning earlier that when you look at the kind of growth that is happening in case of renewables, I have divided them into primarily three different pages. One is publicly supported. If you look at 1990, starting from 1992 and 1993, you see that renewables are primarily supported by the government in terms of the tariff, in terms of the generation-based incentives, GBI, or accelerated depreciation, AD, and all that. Now, and through RPO and feed-in tariff schemes. Now, we moved from that kind of regime to regime which is more like a mix of market mechanism and publicly supported instrument. Like let's say you think of REC, Renewable Energy Certificate, which essentially is mix of representing, because part of it actually discovered by the regulatory commissions, part of it is discovered through market process with demand and supply. So you see there has been a change happening in terms of the instruments that have been created to support renewables, or particularly the policy and fiscal instruments, financial instruments, which have been created over time in supporting the renewables. More interesting phenomenon is coming out recently when you move away from a regulated regime to market regime, where the prices are discovered either through the trading in the trading platforms or through auctions, reverse auctions that are happening in solar and wind space. Now, coal transition debate is also very, very complex. Just to throw some light on this quickly, given the time constraint, we said that the coal transition debate is not that easy because coal is an largest informal employer in this country. Not only that, coal contributes 44% revenue to the state governments, particularly the freight charges to the railway. So you might have seen that the tickets that you buy from the railway is written that this much of discounted. This is the discount that you get. It's primarily because of the fact that coal subsidized your ticket price in the railway. Similarly, coal contributes significantly as a royalty to the state revenue, particularly the eastern part of the country. And there are not only that, there are also other benefits which are accrued from the coal industry in terms of the district development, in terms of the local developments. Importantly, what is happening in the coal debate is that the coal reserves are actually coal reserves are actually there in the eastern part of the country, where renewable potential is mostly in the western and the southern part of it. So when we actually shut down the coal plants, stop coal production, it is not that easy because it might be eastern side is perennially poor, relatively poor compared to the western and southern side of the country. So while the potential lies in southern and western side, the eastern side has the reserve coal. So if you stop coal, it might further aggravate in terms of employment creation, because those who are employed in coal, they're largely informal, unorganized sectors. So you cannot really move them. They're not mobile. So it is really difficult when you stop coal. So coal lock-in is something which India is experiencing. That is why the whole debate on coal phase down and coal phase out happened in Glasgow. Similar debate also is happening in terms of the, I'll just skip this, in terms of the decentralized and centralized systems. So even though we have been we had targets for promoting decentralized energy systems, but we have not really promoted that much. And it has been argued that the Indian renewable energy industry is actually characterized by big players such as Reliance and Adani, and it's called as big boys club. Now, small players, small investors, those who are there in the industry, they are now left the industry. It's primarily the big players. And as a result of which, what is happening, and there are a lot of mergers and acquisitions also happen in that. So the problem is that small, decentralized energy intervention targets have not been achieved. And there is a study which has been carried out by one of my friends here in Terisas, Dr. Sapin Thakur. It has been realized that if you look at the resource requirements for decentralized energy interventions, they are actually less resource intensive. Centralized power plants are more resource intensive. And despite the fact that there has not been progress on the decentralized energy interventions, particularly solar PV, rooftop PV, because of the problems which have not been addressed, which are more social and cultural nature rather than economic and technical. So there has been a whole lot of issues around that. I can share this PPT those who are interested in this. I'll just come. There is also an issue of stranded assets. Because why? Because there are a lot of investment which have already been made in the coal and oil and gas industry, and you do not really know how the law is going to be changed. It's primarily because of the fact that the kind of every year there's been the laws, the sector itself is so dynamic that every year you come up with new laws and new regulations. If there is a law coming up asking the companies to stop coal production, stop oil production, stop gas production, it might lead to creation of huge amount of stranded assets, which has been experienced in some other countries as well. So India has to prepare for that. That's an issue which has not really received a lot of attention in the debate that we are discussing today. So this is what the stranded assets is. So just to come up, I'll take 1 minute to complete this. The idea basically that what will be the temporal trajectory of the transition that we're discussing, whether it will be radical or whether it will be incremental. Or do you want that certain sectors should experience radical changes, certain sectors should experience incremental changes? Have you really taken that into consideration in terms of its socioeconomic implications, its financial implications, when you transit at a rate which is accepted by the society, which is actually creating less environmental impacts, which is also taking care of the economic implications of that? Then there is also the market segmentation, as I said, that given the fact that sectoral transitions happening very different way in different geographies. So every state, at least, would be considered as a different market. So there is a clear market segmentation. If you look at, let's for example, electric vehicle policies unfolding in this country. So you have close to 28 states, 28 electric vehicle policies which are actually drafted, and they're not same. So the way the policies are drafted, the way the policies are implemented will have different implications for different other sectors. So that essentially means that each state will be experiencing a different kind of market structure. So market segmentation is very clear, even though there are broader guidelines coming out from federal government or central government in India. So then balance sectoral integration. How do you, let's for example, if you're growing electric vehicle, have you taken the implications of those growth on the electricity sector itself? You have to take that in consideration, not at a centralized level, also at a decentralized level. There are also, as I said, there are policy level inconsistencies, misalignments, and that might create problems when you look at, let's for example, if there is a target, okay, let's for example, you need to reduce the emissions by 45%. Now, have you really looked at how are you going to do this? Have you apportioned that based on the sectoral targets or based on the geography? Let's for example, you divide the total target, a certain amount of the target to be given to Maharashtra, certain amount to be given to Orissa. Have you really thought about it? That was a debate which also originated when we talked about the RPO. Then creating an ecosystem is something which is very important, has been highlighted in different discourses. This is where I like to stop. I'll happy to take some questions or queries. If I cannot answer, I'll definitely explore that and discuss it. I love to discuss with you later on. Thank you once again for giving me this opportunity. I'm so sorry that I wanted to cover so many things, but I tried to cover at least some of the broad things which are coming up. They're very, very complex and very, very and requires and it basically offers a lot of research potential, not only for now, across geographies and over time. That's what I intend to present to you. Thank you once again for giving me this opportunity. Thank you once again.
Thank you, Dr. Sarangi, for a very elaborate discussion on the energy transition. I think you have covered almost all macro issues except nuclear energy. But yeah, you have rightly pointed out the challenges that India and the global economy are going to face while achieving this energy transition. Okay, now the floor is open for discussion. I think we can take questions from the online participants if there are any. Is Tapan present online?
I think he has left.
Oh, he has left. Okay. Okay. Prat. Prat, you can
Yes,
unmute and yes.
good evening, sir. Am I audible?
Yes, you are.
Okay. Good evening, sir, as well. Gopal, sir, as well. Sir, very insightful presentation. Thank you so much. Sir, I just wanted to ask one thing. This net zero emission, sir, this has to be ingrained until the household level, shouldn't it be? Then if one is curious to know that what is the situation of this entire, one wants to know that what is the situation, what is the background of this entire household energy consumption situation that can be used for transition. Am I, sir, saying it in a proper way that can be understood?
Shall
Am
I
I not-
answer this?
Yes,
Or
sir,
will
sure.
take all the
Yes, you
questions?
can. Yes.
Okay, thank you,
can.
Bharat. I think it's a very valid point which you have raised.
Thank you so much, sir.
I think this is a very complex question as well to answer. Just to throw my understanding on what I understand is that definitely yes, I think household is definitely an important actor in the transition debate that's happening. And there have been some efforts made at the policy level. For instance, let's say talk about Life Mission. Okay, Life Mission essentially focuses on the behavioral changes. Now, behavioral changes, in fact, we did some work in Terry and Teresa's also, that behavioral changes is something which can be nudged. You cannot really force anybody to make some changes. You can create incentive structure by bringing in financial, what do you call, penalties or financial incentives. But behavioral changes is something, let's for example, when we have some mechanism here. Let's say when you leave the room, are you switching off the light, right? That's something which is actually we need to adapt it. Okay. Second is the carbon footprint. Let's, for example, if I give this example, I belong to a village in Odisha. Okay, I know the story. When I go to my village, I directly take a glass of water from the tube well and drink it. Now, when you actually drink the same glass of water in urban area, how many glasses you're wasting when you're actually using a filter? You waste 3 to 4 more glasses of water, right? Now, what should possibly be done in this case? It's happening because of the ecosystem, right? So I think the issue is not that easy to resolve. Third and last one before the ask me the question is about the green credit scheme which has come up by the MOFCC. Please have a look at it. It is essentially trying to look at also, let's for example, if you're planting trees in your backyard, so they are trying to figure out how much carbon emission reduction is happening and whether that can be converted into some kind of credit. And that's actually going over and above of the carbon credit which is being discussed. It's actually green credit, which assumes other aspects of the green growth. I don't know whether I've answered your question or not, but these are basically thoughts which are coming to my mind. And the issue, as I said, is very complex. As I said, let's for example, rooftop PV is not actually being penetrated in Indian context because of the structural problem, right? So there are issues with the distribution utilities, and there are also issues in installing the systems. There are also issues in terms of creating the market mechanism for it. So we are not really actually progressed much in terms of, at least the residential solar PV has not really been progressed much. Of course, institutional industrial development is there. I don't know, Farhat, whether I've answered this query or not, but I just thought of giving you this kind
Yes,
of
sir.
info.
Thank you so much, sir.
Thank you.
Sir, I just
Devjit?
have one more really small question. Can I
Yes.
ask that?
Yes, please.
Sir,
Okay, go
if,
ahead.
like I said, the other part of the question, if I want to know what is the background of energy consumption for the household, sir, how can I get an idea on that, like clarity or a pattern that where is it going or transition wise, what is happening there? How can I get an idea about that?
So the idea basically, if you look at the picture, I mean, it differs. Okay, state to state it differs. For instance, of course, it is a relative difference. For instance, if I say in case of Orissa, the agricultural consumption is only 3%, right? And your residential consumption accordingly grows up. But if you look at, let's say, what is happening in Karnataka or Tamil Nadu and other states, agricultural consumption is 30%. So your relative residential consumption is low, right? And I think the exact number you can look at the data. I don't have. I mean, that's not an issue. The issue is essentially that what would be the focus, because when you talk about the energy consumption, right? So I mean, there is the idea basically that what is your focus as far as the emission reduction is concerned? Is it the source of energy or is it the consumption of energy? On the consumption front, we have in fact achieved something. If you look at what is happening in case of we had a scheme called a short certificate PAT scheme, right? So I think that it's more about trying to reduction of the industrial consumption, which does matter, rather than residential consumption. Because particularly for MSME sector, we don't know what is happening exactly there because there is less data available on that front. Exact number of consumption, you can look at the data, and if you want, I can help you in finding the data as well. Thank you.
Thank you so much, sir.
Yes, Devjit.
Now we can move into Devajit Palit.
Thank you, Gopal. Thank you for, am I audible? No, thank you for the wonderful presentation. This one,
Yes,
you covered almost all the things. Your presentation talked about the complexities. Let me, if I can make a comment, let me add few more complexities and then would like to get your opinion on those complexities. This one, number one, now the two form energy transition that had taken place earlier, what we call the grand energy transition, transitioning to coal and then transitioning to electricity. At that time, scarcity of resources was not an issue. This particular transition that is happening has started long back, actually, almost 20 years or 30 years back. And initially, it was the scarcity of the fossil fuel that was an issue, but now the climate has become more important, and so scarcity of fuel has gone to the background, and climate has come forward. And that's why we are undertaking the transition. Now, the earlier transition didn't address the problem of energy poverty and created more inequity in the world. This transition also had an added responsibility of bringing more equity in the world. Now, how this is going to take place? This is one complexity. The second, the process of energy production from renewables is clean. However, the rest of the value chain is not clean. So that's something that we are not discussing much about, that this particular thing. That means when I produce electricity from solar energy or wind energy, at that point of time, there is no GHG emission. So that process is clean. But however, when I'm mining the silicon or mining the cobalt or mining the aluminum for making the solar panels, that is as bad or as the current mining of coal or other materials or minerals that is taking place. Or when I'm going to dispose of the solar panel, that is as bad as the what is happening with the fossil fuel industry now. Should we not start working on that? And if we are to start working on that, how that is going to impact the speed of transition? Number three, on again, I'll add another complexity. The land requirement per megawatt hour of electricity for coal is along with CCUS, carbon capture and utilization, is around roughly 21 meters square for per megawatt hour of electricity produced. For solar PV with silicon panels, it is about 19 meters square. Now, if I add carbon capture and utilization, then the coal becomes as good as a clean electricity source, and not much difference in land requirement. Now, why we are not working, instead of focusing all our energy or all our investment into the renewable energy, is it not prudent to also put some money into the carbon capture and utilization to make coal clean? Because at the end of the day, solar energy or radiation or wind might be infinite, but the devices that are used or that will be used to convert the radiation into electricity are finite. So are we not creating a new problem of finiteness, which were there? I started with the scarcity of resources. So again, there will be scarcity of resources. So how further we can take forward this transition? So your comments.
Thank you, Devjit. I think I completely agree with your points because they are in alignment. I don't have any answers for all your questions, but they are all relevant questions which requires not only research, also policy actions. For instance, when you talk about equity, nobody knows actually. That's a debatable issue. And how to achieve equity when you actually transit is something, that is going to be seen. Nobody can answer that. Only thing that I would like to say is that probably if, when it comes to looking at equity, and the question is at what scale we are trying to look at it. And for particular sectors, let's say, do you have adequate alternative mechanism for it? Let's, for example, shutting down the coal plants in eastern part of the country, and we don't really, particularly the question for us is also not liquid will come probably later. The first question for us is to find out and take an account of how many employments are there, because when we talk about unorganized employment, when we talk about informal employment, women are banned, let's for example. In practice, for all practical purposes, women are employed. So we don't have a clear account of how many people are actually employed and what would be the impact of job loss. So I think everybody is now writing on that, but I don't know actually what actions have been undertaken that. My research is very limited on that. I don't really have clear answer to that. I think very good point. I think we talk about equity everywhere being discussed at all scales, but when it comes to for practical purposes, we don't know. If I just said I belong to a village, I've seen that. Like for example, if you look at creating, we talked, you and I developed something on the stacked model of cooking energy. Now that model is actually going through a change, primarily because, let's for example, if you look at the price of wood in villages, it has actually skyrocketed. Now electricity is not available. The quality of electricity is very poor. LPG is not being supplied. Price of wood and because of the less livestock population, you don't have your cow dung and all. You don't have agri residue because of mechanization. So the problem is actually getting aggravated when it comes. Let's, for example, I give this example where you have contributed significantly in terms of cooking energy. So I think there is an issue of equity, and that will be there for the longer time period, at least for the next 30-40 years. When you talk about equity, you don't really know whether coal can actually be replaced by renewables and what would happen to the employment and all these aspects. I think the value chain question is equally relevant. There have been some efforts. You know already what kind of efforts have been taken. Particularly in industrial sector, they're trying to look at this through scope 3 emissions, but there is also this issue of greenwashing. And because since electricity or energy is more like a political commodity, they only look at what is actually seen or visible. what is behind is actually not being addressed that much. I think the issues of sourcing of energy, looking at how the mining is happening, and also the fag end of the consumption, disposal, and all that is an issue which has not really been addressed. Even though government has come up with some policy, I think the incentive structure probably would be more what do you call pronounced if you really want to address the supply chain issue, which is more at an aggregate level rather than specific to a particular sector. Finally, land requirement. Yes, I completely agree with you. Land, India is a land deprived country, and we are struggling for land. We don't really know, which way of, when we talk about transitioning from coal to renewables, we don't have really very clear answer actually. What would be the other resources required or supplementary resources that would be requiring? We only look at what is actually the broad change, the grand change, as you said, grand energy transition. We don't really have clear understanding of associated implications, and that actually makes the whole thing very complex. I'm, as I said, I have not really answered the question. I don't really want to answer because these questions are really, each of them requires more thinking, more policy actions, more changes in the ground rather than only discussing through the conferences and all that. Yes, Devajit, any final
Thank you.
comment?
Thank you. Thank you.
Yes, Arundhati.
Thank you. Yes, yes.
Good evening. Hello.
Yes, go ahead.
Yes,
Hello.
please.
Audible? Okay. Good evening, everyone. My question, I'd like MA Energy Economics, Banaras Hindu University. I just completed my internship in All India Limited. So, my
Arundhati,
internship report.
voice is
So the question was like, when we.
Your voice is not audible to us. I think there is
Hello?
some connectivity issue from your side.
Hello.
Could you please type your question?
Hello.
Arundhati, please type your question.
It's hello. Now it's audible.
Your voice is breaking. So please type your question in the
Hello.
chat box.
Hello. Hello.
Minil, you can take other questions if there are.
Now is it audible? Hello.
No, you are not audible. So you can type your question. You can take any other question if there is any here. Will anybody like to ask any question? Yeah, go ahead.
Sarangi sir, namaskar. Am I audible?
Yes, sir, you are audible. Yeah, please go ahead.
Thank you, sir. Sir, in the G20 summit, we saw that Indian government actually focused on the ethanol production, basically ethanol blending of petrols and other products. The idea is that during the oil crisis in 1973, Brazil took it as an alternative because of the fluctuation in the oil price. The entire market crashed, unemployment rose. To protect its economy, it adopted an alternative. It started producing ethanols from sugarcane. So that was an alternative from economic point of view to keep economy independent and not getting affected by the world economy. But later, the narrative changed. We seek for other sources of energy, like the narrative is to protect the environment and to achieve sustainable development, like this. But in that context, I would like to ask you that we see the challenging, issues in terms while you are trying to produce renewable energy in India and as well as other countries. The challenges commonly includes like the cost of installation and the like if it leakages nuclear energy, if it leakages the damage effects, and also the challenges of deposit and storing nuclear energy and the waste management. So these are the challenges. But in case of ethanol production, these challenges are minimal. The cost is very low and it is very environmental friendly. And we have seen how Brazil actually become a developed economy in the after 10 years of producing ethanol, that it started producing more than 2,000 tons liters at 2,000 tons per year. So why can't we shift our focus to this biogas production? I mean, the global biogas alliances, the focus of global biogas alliances. Why can't we focus our energy towards this kind of energy rather than nuclear energy?
Okay, shall I answer that?
Yes. Please.
Okay, thank you. I think this is a very important question that you asked. And there is a debate going on around even though we had this mission announced in G20, but the debate is not new. Debate has been there for some time. The debate is basically, there is a debate happening in the country between the food and energy. I told you that India is a land deprived country. So there has been a discussion happening that if you're actually growing the energy crops, right, then you would be fulfilling sort of food requirements. There have been studies made in Indian context is that if you're actually getting into more energy crops, where would you grow the paddy and the wheat, right? So, and what would be the balanced way of looking at this is something which requires a lot of research. Let's, for example, have we really projected what would be our food demand? Because food consumption pattern is also changing over time. Right? That's one thing. Second is that what would be our energy requirement? And second is that when we talk about, I think we talk about energy composition or use of energy particularly. India is a vast country. Okay, don't really cannot meet all your energy requirements by only relying on one source. You need a portfolio approach. That means, yes, if you look at, let's for example, transport sector, there has been, it's not new. Okay, the ethanol mixing or blending is not new. It has been happening, and there is a trajectory that it would increase. At the same time, you also promote electric vehicle. At the same time, you're also promoting non-motorized vehicles, metros, and all that, right? So there has been a whole lot of what you call pathways which can be combined. You cannot really rely on one pathway. So ethanol production is definitely good, but we also have to figure out what would be the maximum that you can go, because of the fact that there is a debate on food and energy. In fact, there is a trade-off. If you grow more energy crops, you might be facing a food crisis. That is one. Second, of course, there has been not only in this G20, if you look at 2 months before, there has been a discussion happening that in the aviation industry, the ATF, okay, ATF, which basically kind of kerosene, refined kerosene, which is used in the aeroplanes, right? So they now want to introduce from 2025 onwards, the plan is that 1 to 2% of blending would happen. So, but the problem again is technology. Problem is commercializing the technology, bring it to saturated level so that actually it is marketed. So the issue again is not very simple that will be showing, okay, only focus on that. You need nuclear, you need ethanol, you need electricity, you need petrol-based, diesel-based energy. So it's not that easy that you should, but at what level you want to leave one energy, move into the other one. What would be the trajectory? There have been a lot of studies being done, but all these are not, I mean, giving a clear answer. There is even at a policy level, there exist a lot of uncertainties, right? Who is going to bear the burden of production of ethanol? Punjab, in fact, there is a whole lot of discussion, because at individual level, it is actually a boon, but for a country level, it is a vice. Individual level, you would be happy because you actually rent out your land because paddy growing Orissa. What is happening in Orissa? So you just rent out your land for solar production and you get annual money. But what would happen to country? So for individual, it is a boon, but for a country, it is a vice. So there are debates. What is good for a country may not be good for an individual. What is good for an individual may not be good for the country. So these debates requires a lot of research. And in fact, I'm happy that the NISER DST Center is actually looking into some of these issues at a regional scale. And in fact, the most important thing that is the need of the hour is to look at how these things are getting unfolded at a very decentralized scale. Thank you once again for the question.
Okay, I have one question. No, at TERI, since you are doing a lot of research on energy, related issues, I am still wondering. Like my personal notion is that in a biofuel is something not to be encouraged at all, because this can really create food scarcity. And but coming to the other energy sources. Whether TERI has any studies to find out the optimal combination of energy basket for India, because you are quite silent on nuclear energy, and you have already pointed out that solar is quite land intensive, and wind, we don't know actually the reliability because of the wind speed and other. Because when we are doing a survey of the eastern Indian states, we observed that wind is almost a non-starter in eastern India, or if at all, it's very little contribution is there. So and also eastern India faces a lot of cyclones and disasters. So that way, we don't know whether we can use windmills. So what would be the real optimal combination, or what would be the future of India's major energy source?
Yes, I think this is a very difficult question. Yes, I think you can. I mean, when it comes to looking at optimal combination, there have been a lot of projections made by TERI, other organizations, CEW, CSAP, many organizations that are working on those who are working on the field of energy. They have come up with optimal combination. But I think all these, I mean, TERI also long back when Professor Devjit Palit was there earlier, that time also they projected, okay. But the problem is that the sector is so dynamic and technology transformation is so vast and so fast. You cannot really predict what would happen in next 2 years. Forget about predicting or projecting for 30 years or 40 years now. You don't really have an idea. Nuclear is silent because of the obvious reasons. One is that the technology transfer is not happening. Second, nuclear acceptability of nuclear projects is something which is problematic by the Indian citizens. Third is that there has been some development as far as the small nuclear reactors, which could possibly be used for producing small amounts, particularly for the civil purposes. That discussion is going on. But I think the solar is going to be the major thing. But I think if you look at the green hydrogen, okay, we didn't touch upon that, but green hydrogen is an area which is upcoming. Now, the problem for the green hydrogen because your input is renewables. Now, if you're actually, let's for example, give you a very crude fundamental statistics of how the green hydrogen, for 1 kg of green hydrogen, you need 50 to 60 kilowatt hours of renewables. And you know that renewables are very less efficiency, very low efficiency. So the problem is that how much of renewables do you really need if you really want to meet your green hydrogen? And then again, the problem comes down to what even Professor Palit said and what I mentioned is about the land requirement, water requirement. How are you planning to be unfolded at regional level? So solar and wind has, of course, the potential. Wind has not been explored in eastern part, primarily because, as I said, all these sectors are grown by the private sector. And whenever there is private sector only looks at where there is, I mean, how can they actually tap the low-hanging fruits? They found Tamil Nadu, Kerala, Rajasthan, Gujarat, other places where actually it is possible for them to explore. They've done that. But once those places get saturated, probably they now move to, and there have been new findings coming up, particularly in eastern side. If you specifically talk about Orissa is going to be the energy hub now because you have rich in coal bed methane, rich in gas. Mahanadi basin is high in terms of the reserves as far as the gas is concerned. There are plans to set up offshore wind energy within the Orissa belt. And there are also, as I said, a lot of potential exists as far as solar and wind is concerned. But one is that the problem why it has not been developed is primarily because that these sectors are actually developed in the country by the private sector. And either the private sector has not really been interested to put up the money there because of the fact that they are actually trying to get the low-hanging fruits which they have got in Gujarat and Rajasthan and other places. Second, that we actually did some work earlier where we looked at that some states are leaders in attracting the private investors. For example, Rajasthan, Gujarat, Tamil Nadu, all these. Orissa is probably, okay, nobody knows, has not been able to attract private investors into the state in promoting renewables. But as I see, nuclear has a role in future, but solar and wind and green hydrogen, all these are important. But at the same time, what is most important is basically the storage. If you don't really build the storage system, it is not going to be very helpful, because this is what the future will be looking like. Thank you. I don't know whether I have answered the query. I try to bring out some insights in that.
No, I understand this is a very complex question. No, if you will have the answer, then you don't have to do any research in the coming days. So, yeah, okay. I think you can take the question by Arundhati Pandey. She has already typed the question.
Right. Okay. What should be a fast step in energy transition? Transition over green energy from coal to renewables for industrial purposes. See, I think again these questions that Arundhati have asked, there is no answer to it. There is nothing called fast and last. You have to move. As I said, that the important point for us is to create that portfolio, and it has to happen at all scales. Neither because energy is in the concurrent list. So sometimes center says something, states do not listen. So that kind of political economy conflicts are also there. And nothing is fast, nothing is last. You have to bring in the portfolio. You gradually diminish one subsector of energy, increase the other subsector. I think this is a very direct answer. I would be happy to discuss with you further if you really want to do that later on. Thank you.
No, your answer is complete.
Yes.
Oh, okay. So, are there any other questions from the floor? Okay, so if there are no other questions, then I think we can close the meeting today. Chandrasekhar, are you there? No, I think he has already left. Okay, so I think we had a wonderful session. We covered all the macro issues related to the energy transition, and for me, at least the learning points are that India's target of achieving net zero is probably quite late, actually 1970. So advanced countries have already achieved, kept the target quite earlier to us, and they have already included this target in their legislation. We are at only policy stages. So India has a long way to go, but we are working quite hard to increase the renewable energy production. So, okay, so I think with this we'll stop, and I would like to thank you, Dr. Sarangi, for initiating this presentation. Although it got delayed exactly by 1 month, right? We had planned for starting this lecture, I think on August 18th, but it got delayed. But better late than never. I hope we'll be getting many more speakers to deliberate on these issues in the coming days. So with this again, I thank you, and I look forward to your collaboration in the coming days. Thank you so much, Dr. Sir.
Thank you. It was a pleasure for me to be here and discuss with all of you. Thanks a lot for inviting me. Happy to contribute whatever I could. Thanks a lot again. Have a great day.